Hey everyone, welcome to my channel. This is the Object Detection 101 course. In this course, we will cover everything to get you started with object detection along with 4 exciting and real-world projects. We will first start with the theory and have a look at its brief history. Then we will understand the working of object detection along with its evaluation matrix. From there, we will install everything from the start and run the YOLO version 8 object detection pre-trained models. Using these models, we will create 2 projects, car counter and people counter. Here we will learn how to implement object tracking along with object detection. We will also install and run YOLO with our GPU for better performance. Later, we will learn how to train a custom YOLO model using our own dataset and create 2 projects using our own training. The first one will be personal protective equipment detector, and the second one will be poker hand detector, where we will first detect the playing cards and then create a classifier to classify the correct poker hands. If you are a beginner, don't worry, this course is for you. We will go step by step so it is easy to follow. This is an information-dense course that will provide you with maximum knowledge without wasting your time. Learning custom object detection is a superpower that can allow you to solve real-world problems, and it can be easily completed over a weekend. So buckle up and get your nerdy glasses on and let's get started. But wait, we are going to use NVIDIA's 3080 Ti graphics card in this course. Now my question to you is, would you like to have one too? If yes, then you are in luck. I will be giving away a 3080 Ti graphics card, and all you have to do is register to NVIDIA's GTC 2023 conference through my link in the description and attend one of their sessions to enter the giveaway automatically. The conference will be held from 20 to 23rd March 2023. This is a great place to learn new things and keep up with the new trends in technology. So sign up today and I will see you there. What is object detection? Object detection is a computer vision technique for locating objects in an image or a video. Object detection gives us the bounding box information of the object as well as the classification of that object. What is the difference between object classification, object detection, and object segmentation? Object classification is a type of image recognition that identifies what type of object is present in an image. Here, the complete image is sent for classification, so the output is a single class. Object detection is a type of image recognition that is used to identify and locate the presence of an object in an image. This gives us the bounding box information and the class as well. Here, the results can be multiple bounding boxes and classes. Object segmentation is the type of image recognition that is used to identify and separate the distinct objects in an image on a pixel level. Here we get the exact shape of the object detected rather than just the bounding box. Although image segmentation provides more information, image detection is still the first choice for most computer vision applications since it is less computationally expensive. A brief history of object detection. Object detection was first started in the 1970s. Researchers started to develop automated methods for object detection. The first automated object detection algorithm were based on simple features such as edges and corners. The first real object detection was Viola-Jones, developed in 2001. It used sliding windows to search for hair-like features, which are simply rectangular features. This method became popular since it was real-time. For the longest time period, this method was used for face detection in smartphones and cameras. The histogram of oriented gradients was another method released in 2005 that focused on the shape of the object. It worked by extracting the gradient and orientation of the edges. This method was mostly used to detect humans in an image. Then came the revolution of AI, with neural networks gaining popularity. The true potential was seen with convolutional neural networks when AlexNet won the ImageNet Large-Scale Vision Recognition Challenge in 2012. But this solved a classification problem and not detection. Later, brute force methods were used to repurpose the CNN models to work as detection models. This was a very inefficient approach, so soon after came the RCNN, regions with CNN. that used selective regions to apply the classifiers. This gave good results, but it was slow. So then came the fast RCNN and the faster RCNN, which were faster but still not real time. In 2015 came the breakthrough of YOLO. This outperformed all the other models and ran object detection in real time. This was a different approach as it used single pass of the input image to make predictions of the objects. Methods like RCNN used regional proposal to perform multiple iterations for the same image, while YOLO gets it done in a single iteration. This makes YOLO more efficient even though the architecture of YOLO is based on convolutional layers similar to its predecessors. Since then, YOLO versions have been releasing faster than Andrew Tate's $5 million Bugattis. Every time I come back from the toilet, I have to check if a newer version of YOLO was already released. But don't worry, the change between each iteration is not always very significant. It's like Apple telling us how their latest iPhone design is completely different from the previous one. If you don't believe me, have a look at these results. Can you guess which is the latest model?
Absolutely not.
So even if a newer version comes in, the previous versions don't go out of date. Performance evaluation metrics. In order to evaluate our object detection models, there are two main metrics that we need to understand. One is to evaluate how good is the location, and the other is how good is the classification. First is the IOU to measure the localization, and the second is the MAP for classification. IOU stands for intersection over union. It tells us how close the predicted bounding box is to the ground truth. It's a value between 0 and 1. If the boxes overlap, then it's a perfect detection with an IOU of 1. If the boxes have some overlap, then the values are between 0 and 1, depending on how much the overlap is. If there is no overlap, then the IOU is 0. The value of IOU is calculated by taking the ratio between the area of the intersection and the area of the union of bounding boxes. In order to understand average precision, we need to know confusion matrix, precision, and recall. Confusion matrix is a simple table that consists of actual classes on one side and the predicted classes on the other. Let's have a look at an example of a car classifier. In the first cell, the actual class is of a car, and the model predicted it as a car, so it's a true positive. In the second cell, the actual class is a house, but the model predicted it as a car, so it's a false positive. In the third cell, the actual class is a car, but the model predicted it as not a car, so it's a false negative. In the last cell, the actual class is ball, and the model predicted it as not a car, so it's a true negative. This value corresponds to not predicting a bounding box and is usually the background, so it is not used in the metrics calculations. Using these values, we can calculate the precision and the recall. Precision is the total positives out of the total positive predictions. Recall is the actual positives out of all predictions. In mathematical terms, precision is true positive divided by true positive plus false positives. Recall is true positive divided by true positive plus false negatives. Since both metrics provide us valuable information, we combine them to one called the precision average. This is the area under the precision recall curve. The precision recall curve maximizes the effects of both the matrix and give us a better idea of the overall accuracy of the model. This average precision is of a single class. If we have multiple classes, then the mean of these precision values is the mean average precision, also known as MAP. So the first thing we will do is to download Python, and to do that we can go to python.org. So we will simply go to downloads, and here you can see you can download the latest version, but that is not recommended because it might have some errors or it might need some bug fixes. So we'll go to all releases, and here we'll go down, and you can see Python 3.11 will have support till 27. Python 3.10 will have till 26, so you can see the information here. So this is basically the long-term support. So here in the release version, I would suggest to go, don't go for the latest one, go for the one that is one below the latest one. So for example, here you can see 3.10.9. So we can download this. We can simply press on download. And here you will go to Windows 64-bit and you will click on that. So it will start the download. Now you can have multiple versions of Python as well. So you can have the same project running on different Python versions. So you can see which one is more stable, which one gives you better results. So I will show you how you can do that because I already have Python 3.7.6, which I have been using for the longest time period. And I will also show you how you can use Python 3.10 in this case. So we will be using Python 3.10, but if we had to downgrade, I will show you how you can do that. Or if we had to upgrade, I will show you how to do that as well. So what you will do is you will click on Python. So here, make sure that you add python.exe to the path and you will click on install now. Okay, so the setup is done and we can close. Now we will go to PyCharm, which is our IDE. Now, if you're not familiar with IDE, it stands for Integrated Development Environment. It's basically a notepad where you can write code, but it will help you out to write the code. It will tell you where the problems are, how to fix the bugs and all that. So what you will do is you will go to PyCharm. So this is jetbrains.com/PyCharm. And you will go to download, and in the downloads there is a professional version and there's a community version. So you have for Mac OS and Linux as well. So we will be working on Windows, so we will download for that. So for the community version, you can simply hit download because it is free and it is more than enough for what we need. So now the download has started and we will wait for it to finish. So now the download is complete and we will hit on PyCharm community. We'll click on next, and we will associate .py files with that. We'll add bin folder to the paths, and PyCharm Community Edition will create the desktop icon as well. Install. Then we are going to restart our computer and hit finish, and then we are going to open up PyCharm. So this is not the first time I am installing PyCharm, so it has some memory of what I've been doing. So it has some of the default parameters. So you might see some pop-ups that will ask you a few questions, how to set up a few things. So you can set them up, click next, and it should be fine, or you can close them. And the main thing that I'm going to tell you that you need to do is right now. So you will click on file and you are going to create a new project. And here is the main thing. So this is an environment. So basically what you do is you have the actual Python and you copy that basically, and you create a virtual environment that is separate to everything else. So this project will have its own environment, and whatever you install will be installed in this environment. So this is based on a specific version of Python. So here the base interpreter you have to mention. So right now the base interpreter is Python 3.1.0. So you can also have Python, for example, 3.7. So I have these two, Python 3.7 and Python 3.10. So I can choose between these two. So for now, I'm going to choose, for example, this one. So what I will do is when I'm creating the environment, I'm putting down the name and I can write environment and I can write 3.10. So this has a version as well. So here we'll just name it Python project and we are going to hit create. So we will use the same window to create this project. And here we have our Python project that is created with the main file. And you can see the virtual environment 3.10 has been created. So what I can do is I can remove all this and I can simply write print hello world. So let's go ahead and right click and we are going to run main, and this will give us hello world. So this is running Python 3.10. How do I know this? Is because you can see here we have Python 3.10. We don't have Python 3.7. So what we will do is we are going to go to File, and any package that we want to install, we can go to Settings, and then we will go to Projects, Python Project, and we'll go to Python Interpreter. And here we can add any package that we want, whether it's OpenCV, whether it's CVZone, whether it's Ultralytics, whatever it is, you can install here. So for example, we can go ahead and install NumPy. So we will click on install package, and it will take a while, and you can also specify which version of NumPy do you want to install. We are installing the latest one that is available right now. So we can hit close, and here you can see now in the packages we have NumPy installed. This is the current version and this is the latest version, so they are up to date. So these three are already installed, so you don't have to worry about those. Then we can simply click OK. So here if I write imports NumPy, and if I run this, it will not give me any error, which means NumPy has been installed. If I write anything else, it will give me an error because there is no library called num2y, right? So that's the basic idea. So this is import NumPy. Now, if I go to File and if I go to Settings, I can create a new virtual environment. If I wanted to use two different Pythons, I could create a new virtual environment. To do that, you can click here, you can go to Show All, and over here, we can click on Add. So here we can create a new environment, and here we will create for 3.7. So we will select 3.7 as our brace interpreter, and we have named the virtual environment 3.7, and then we'll press OK. So now it will create and it will shift it to 3.7. We'll hit OK, but now you can see that we installed NumPy earlier, but it was installed in the virtual environment of 3.10. But now it's not installed in 3.7 because we are now using 3.7 as the main environment. So that's why it is giving us an error over here. So if I run this now, it will give me an error that there is no NumPy. But if I click here and go to 3.10, and then it will load up, and if I run it again, it will not give me an error because NumPy is already installed. So you have to make sure that your libraries are installed if you are trying different versions of Python. So here you can go to library and you can see you have NumPy installed. So here in 3.7, you will not see NumPy. So what you can do is if you wanted to use in 3.7, you will make sure it's 3.7 over here, and you will go to File, Settings, and here you are going to install NumPy. Now it will install it to 3.7 as well. So the reason I'm telling you this is because later on you might face some issue in, for example, 3.12 or 3.15, and you might want to downgrade or you might want to upgrade later on. So instead of creating a new project and doing all of these things together again, what you can do is you can simply have a new virtual environment and have the same project running. So it will not be very difficult to debug. So here you can see we have installed NumPy for 3.7 as well. So now if I run with 3.7 or 3.10, it will run with both. So for most project, we are only going to use one Python environment. We will usually use the higher one unless there are some major issues in that. So then in that case, we are going to downgrade. So now that we understand how to install PyCharm and how to install Python, you can add more Python versions. Now we can simply go ahead and start working on our project. So here we are going to create our PyCharm project, which is Object Detection YOLO. And we are creating a new virtual environment, and the environment is based on the base interpreter of Python version 3.1.0, so 3.10. So it is up to you which Python version you want to use. So we are using 3.10. If you have a newer version, you can use that too, but don't use the latest one because it might yield some errors. So what we'll do is we'll simply hit on create. And there you go. We have our project. And here we have a main file. So what we can do is we can use this main file to test our code. We can simply write print hello world, and we can run it just to see if everything is working, and it's working fine. So in order to get started, what we have to do is we have to do some installations on this virtual environment. So if you look at this folder, we have the virtual environment. If you click on that, in the libraries, these are the site packages. We need to install some packages in order to run our project. So how can you do that? You can go to File, Settings, and in the Project Python interpreter, you can click on Add. You can type in the version. For example, you can type in the site package name, for example, CV Zone, and you can hit Install. Now, when we are working with object detection, there's a lot of libraries that are working at the backend. So installing them one by one will take a lot of time. So what you can do is, a simple way of doing this is copying a requirements file, or you can create your own file as well. So here, this is a standard version. This is a standard way of doing this. So what you can do is you can simply paste requirements.txt in this project. So where do you get this requirements.txt? You can download it from our website, computervision.zone. It is free to download. All you have to do is sign up. If you already have signed up, just sign in with your account, go to the course page, and there you can download everything related to the course absolutely free. So you don't have to pay anything. You can just download and you can copy it here. So here you can see, as soon as we copy the requirements.txt file, it will give us a notification, package requirements. All of these packages have not been installed. So what you can do is you can click on install requirements, and it will install all the requirements that you need. So what do these mean? So for example, CV zone double equals 1.5.6. This means use the exact same version 1.5.6. Don't use anything above it. Don't use anything below it. The exact same version. So right now I'm using Python 3.10. So with this, all of these versions should work fine. Now, when it is greater than or equals to, then it means that use this at the very least, or if there's a newer version, use that instead. So this can be a little bit dangerous or tricky, because if the newer version is not compatible, it might not work. So you have to be careful which ones are you hard coding to be exact same version, and which ones are you saying. For example, here for Python, we have hard coded it to the exact same version. Normally it's not done like this, but because the latest version has some issues in auto correcting, we are going to use 0.60. This is the version that does not have this issue. So that's why I have hard coded it to be this exact version. Now, if you have a later version that works fine for you, that's okay. But if it doesn't, then it's better if you use the exact same thing. Now, sometimes what happens is that you install everything, but some of them do not install. And again, that might be the issue of that it's not compatible. They don't have a version that satisfies the requirement. So what you can do is you can downgrade or you can upgrade. It's based on that. For example, scikit-learn, for example, this scikit image, let's say it doesn't work, or we can simply comment it and it will remove it from the installations. So later on, if I give it a wrong number, let's say like that, it will give us an error that it was unable to install. So in that case, either you can come here and fix the number here based on the version, or you can go to File, you can go to Settings, and in Add, you can search for what was the spelling? Scikit, I believe. No, SCIKIT -image. Yeah, so you can click on that. You can specify version and you can select which version do you need. it might be a higher version, it might be a lower version. So if the latest one doesn't work, go to the previous one by default. Okay, so that being said, let's just install everything. We will click on install requirements. It will ask us that, do you want to install all of these? We will say yes, install, and then we are simply going to wait for the installation to complete. So the main library that we are using is Ultralytics. That will provide us with the YOLO package, and it will download the YOLO weights for us as well. So we will be using version 8 of YOLO. And if later versions come up, you can use those too, depending on whether they are related to Ultralytics or not. So all of these packages are being installed, and let's wait for it to finish. So all the packages have now been installed. As you can see, all of them are installed and we are good to go. So what we can do is we are going to create a new folder, and we are going to call it chapter 5, and within chapter 5 we are going to say running YOLO. So then we will right click and we will create a new Python file, and we will call it YOLO basics. So there you go, we have our first file, and all we have to do is we have to test whether the YOLO will work or not, and how exactly can we run it. So in order to test YOLO, we need to have some images. So we are going to run it on images first. Once we know it works, then we are going to try it with webcam in the next chapter. So we have some images. Again, you will find this on our website. Once you download the zip file, everything will be included in it. So here you will see we have images, and if you open up images, the first image is of a school bus with some kids going into the school bus. Then the second image is of cars, and the third image is of some bikes, so motorbikes. So these are the three images that we are going to test on. So once we have that, now what we have to do is, first of all, we have to import Ultralytics. So we are going to write from Ultralytics imports YOLO. So that is what we are going to import. And then we also need to import CV2. And I will tell you why. Okay, let's just run it and I will tell you why later on. So it is very simple. With only 2 lines of code, you can simply run your model. So first of all, we are going to create the model. We'll call model equals YOLO, and then we are going to give in the weights. So there are different types of weights. You have the nano, the medium, the large. It's based on you which you want to use. Now, the good thing about this method is that you just type in the name of the weights that you need, and it will download the weights for you. So for example, we will write YOLO version 8, and we are going to write N for nano. So this will download the nano version. So we will write here PT. Then we simply have to write results equals model, and then we have to give in the source of the image. So the image source is basically images slash, and we can write 1.png. So this is our image. And then all you have to do is you have to write show equals true. So we want to see the image at the end. So there you go. So if we run this now, right click YOLO basics, we are going to run it. Let's see what happens. First of all, it will download the weights. Once it's downloaded, it will tell you that it is running on CPU. So that is another thing we are going to discuss later on, how to run it with GPU. But for now, nothing happened. It did run the image. It told us that it is running at this speed and this is the size, but it didn't actually show us anything. So what exactly happened? It actually opened up the image and it closed very quickly because there was no delay. It just opened up and closed. So we need to stop it. So here we will write import CV2. In order to stop it, we will simply write CV2 dot wait key, and we'll give the delay of 0. 0 means that unless the user inputs, don't do anything. So if we run this now, this time around, when we run it, this is the image that we get. So we have the bus being detected, we have the person being detected, handbag, backpack. So there's a lot of good detections here, and they are also giving you the confidence level of each of these. So 0.35, 0.78. Of course, the higher the confidence value, the better the detection is. So this is quite good. We can close that. But here again, you can see that we have downloaded the weights and they are in our chapter 5 folder. Now, in order to make it a little more efficient, we don't want to download it for each chapter, because each chapter or each project, we are going to have some weights. So if we are using the same weights, we should not have it being downloaded every single chapter. So what you can do is you can create a new folder in the object detection YOLO. We will create a new directory and we will call it YOLO weights. And we are going to put our weights within YOLO weights. When we refactor it, now it's in the YOLO weights. So here we can go back, double dot slash, that means go back. And then we will write YOLO dash weights slash YOLO 8n. So if we run this now, it will run exactly the same way because it is able to find this file within this folder. So if you want to try out different versions, you can simply change the name here, and you can write, for example, large, and we can try to run it and see if it works. So it is downloading now, and once it's downloaded, it should give us the results. So nano will be faster, medium will be a bit slower, large will be slower, and you can check out the other versions as well. Which one do you prefer? So this version is 83 MBs. I'm not sure how much was this. Let's open that up. Okay, this one was 6 MB, so it's a huge difference in terms of weights. So there you go, it has been downloaded, and now you can see we are getting better results. We have multiple results here. We also found the skateboard, which was not found with the nano version. And there was a wrong detection here for the bus. That is not detected as well. But here it's saying handbag when it's a backpack. So that is still a mistake, but it works fine. So there you go. So this is how you can download and you can run the models. So what we can do now is we can run images.png2. So let's see how that works. So there you go. So you have lots of cars being detected, some with confidence of 0.88, some with 0.85, some with 0.67. You can see the pattern. The closer it is to the camera, it actually detects it very well. The further it is from the camera, it might not detect. Basically, the idea is how clear is the sight of viewing. So if it's able to detect, if it's able to find the car a bit more, it will be easier to classify, it will be easier to detect, and the confidence level will be higher. But if it's far, if it's blur, then of course the confidence level will not be that much. So that's the basic idea. And then we'll go to images 3 and let's see how that works out. So right now we are using the large version, and you can use the nano version as well. Okay, there you go. So here we have a lot of detections, motorcycles, and we have a truck at the back. We have a person, and they are overlaying on each other, and it's a little bit difficult to see what exactly is going on. And right now we are not really telling the system that put these bounding boxes and put the names and the confidence level. This is done by default. When you are saying show equals true, then it's doing all of that. So what later on what we'll do is, in the next chapter, we are going to put all of these manually ourselves. We will not use the default version, and that way we will have much more control on how we can see, because right now they are overlaying on each other and it's not very clear. So it's not very useful in terms of viewing. So that's the basic idea. That's how we can run different versions of YOLO, the large, the nano, the small, the medium. So here, if we write M, by the way, I wanted to check if we run it with the nano, what exactly happens? How many detections do we get? So there you go. So it says a car, and the person is not detected. That was detected earlier. And actually, let me take a screenshot of this, and I will open it up in Paint. So this is the one with the nano, and let's run it with large, and then we will compare. That will be a fun experiment. Exactly how much are we getting when we are using the heavier version? Okay, so here you can see we do have. Can we? Yeah. So here you can see we don't see the truck. We have some motorcycles. The cars are limited here. Here we have more cars. Here we have less. And here we have a red, which is for a person. Here we don't. And here there's another truck at the back, which is green. We don't get that. So yeah, definitely we are getting more, but is it correct or not? That is yet to be seen. So based on your requirement, whether you want it fast or whether you want it highly accurate, again, all of these methods, all of these versions, they are good, not in a very general sense. But if you have a controlled environment, for example, you're detecting cars or you're detecting pedestrians in a fixed environment with a fixed camera, then yes, it can be very useful. You can have certain limitations, certain constraints, some certain constants that this will always be this. You can add a mask that do not detect in these regions, only detect in these regions, and things like that. It will definitely be useful to put it in your project. So that is exactly what we are going to do. First of all, we are going to run it with our webcam, and then later on we will try it with different projects, how we can implement this in real time. So now in chapter number 6, we are going to run YOLO with our webcam. So let's see how we can do that. So we are going to need the help of OpenCV in this case, and we are going to put bounding box ourselves manually so that it is easier for us to decide what to display and what not to display. So what we'll do is, first of all, we'll go to new and directory, and then we are going to write chapter 6, and chapter 6 is YOLO with webcam. So then we are going to right click and we are going to create a new Python file, and we will call it YOLO webcam. So first of all, we are going to import Ultralytics as we did earlier, and we also have to import Python. So we will, not Python, OpenCV. So we will write from Ultralytics import YOLO, and then we will write imports CV2, and then we will also import CV zone. So CV zone we will be using to actually display all these what do you call detections. It will make it a little bit easier. You don't have to, but it will make a little bit easier. So the first thing we will do, we will create the webcam object. So we'll write cap equals cv2 dot video capture. So this is what I was referring to earlier. So if you are not getting any suggestions, so if you write dot video and you don't get any suggestions, then it means you probably are using a newer version of Python of OpenCV. So, and this is the issue that we are getting with the newer versions. So where is it? OpenCV. There you go. So OpenCV, as you can see, we are using version 4.60, whereas 6.8 is the latest version, but still 6.8 has this issue. That's why we are using 6.0. So we will write cv2.video capture, and the video capture ID, basically you have to give in the ID number for your webcam. I'm using multiple webcams, so I will give the ID number 1 because that is what I'm going to use. But if you are using only one webcam, if you don't have multiple webcams installed, then you should write 0 instead of 1. So I will write here 1, and then you can specify cap.set. You are going to set the width and the height. So the width basically is prop ID number 3. So you can write 1280. This is the width, and cap.set, that is the prop ID number 4. That is 720. So this is the height, and we're going to set it at 720. So this is the basic idea. And again, if you wanted to, there's another one which is mostly used in webcam, 640 by 480. These dimensions are commonly used. So it's up to you which one you want to use. Then we are going to write while true, and we are going to write success, and the image equals cap.read. And then we are going to write cv2.imshow. We want to show the image, so we will write image and img, that is the image we want to show, and cv2.waitKey because we want to give it 1 millisecond delay. So this should run our webcam by default. So if we right click and run, we should have our webcam running. There you go. So this is the webcam, as you can see me. It's running live. So we can close this, and if you wanted to, you can write 1280 by 640, and not 640, 720, my bad. 1280 by 720, and that should work as well. There you go. So now you have a bit more area to work with. So again, it's up to you which one you want to use. So we'll keep it on this, and let's go ahead and create our model. So the model, as we have seen earlier, if you go to YOLO basics, here you can see this is how you can create your YOLO model, and then you can find the results like this. So here we are going to write model equals, we are going to write YOLO, and then we have to give in the weights. So the weights, we are going to use nano for this purpose. So we will go back, we will write YOLO dash weights, and then we will write the version. So this is YOLO version 8 and nano. So YOLO version 8 and nano. So I wrote 1y extra. So version 8 and nano dot pt. So here we will go down and we will write the results equals model, and we are going to give in our image, and we are going to write stream equals true. Now, if you write stream equals true, it will use generators, and that will be a bit more efficient than without it. So it is recommended to use stream equals true. So if we run this now, let's see what happens. So we should not get any errors. That's what we are trying to check. If we are getting any errors, it means we are heading in the wrong direction. There you go. We are not getting any error. So that is good. So now once we have the result, what we can do is we can check for individual bounding boxes and see how well it performs. So here, once we get the results, we are going to loop through them. So we are going to write for R in results. We are going to get the bounding box of each of the results. So we will write here box is equals R dot boxes. And now we have to loop through the boxes. So we will write for box in boxes, we are going to find the XY of each of the bounding boxes. So there are two methods. you can use xy, which means x1, y1, x2, y2, or x1, y1, and width and height. So which format do you need? It depends on you. So here you can write box dot xy, or you can write box dot xy width height. So which one do you want? So I would recommend xy because it will be easier to input directly to OpenCV. So we will write here x1, y1, then x2 and y2 equals this. And what we can do is we can print these values. So we will copy these and we are going to simply print them. So let's see, what do we get? So we are getting an error, not enough values to unpack, expected 4 got 1. So it means they are just packed inside. So what we need to do is we just need to get the first element of it. So hopefully that will work out. There you go. So this is what we are getting. So we are getting the value of 279, 103, 1038, and 7112. So again, then we have multiple detections. Then we are getting two values. So here we are getting x1, y1, x1, x2, and y2. So these are the values that we are getting. So what we need to do is we need to convert them into integers so that we can actually use them. So we can copy this part and we can paste it, and then we can put it into integer, convert it into integer, and integer, and integer. There you go. So let's run it and see if it works. So there you go. Now we are getting the values. You can see here we are getting the actual values that we can use with OpenCV. So let's go ahead and create a rectangle to actually find out if we are getting the correct bounding boxes or not. So here we will write cv2 dot rectangle, and we will give in our image, and then we have the points, so x1 and y1, then we have the x2 and the y2. So these are the points that we'll give in, and then we have the color. So color, let's put it it's B, so let's put it at 0. Green is, let's 200 and 0, or let's make it purple. So 255, 0, 255, that will make it purple. Okay, then we have the thickness, let's put it at 3, and yeah, that's pretty much it. So let's run it and see if it works. And there you go. So we are detecting. So if I bring in my phone, you will see there's a bounding box around it, and it shows that it is working fine. So let's try a pen. Can it detect a pen? Yeah, it detects a pen as well. It detects the phone, and let's try the remote. It detects the remote as well. But again, we are not actually getting the feedback of what exactly the class is and how confident it is. So we are going to detect those as well. Now, as I mentioned earlier, you can use a fancy rectangle as well, which we provide in CV zone package. So in order to do that, you can simply write CV zone dot corner rectangle, and you will give in the image. And all you have to do is give in the bounding box. So you can write here bounding box, BBOX. So where is this bounding box coming from? This is actually XY width and height. So we can get that too. So we can write here bounding box XY width height. And this will give us the X1, Y1 will be the same. And then we will have the width and the height, and then what we can do is we can put it in bounding box. So BBOX equals this. We'll convert it into integers, and there you go. So this will be width and this will be height. There you go. Now this is a repetition. So again, we can use one of them. We don't have to use both of them at the same time. So let's put this one over here. So this one, and let's put this with it. So you can use either one of them. So not both of them at the same time, because that would be weird. We can remove that. So this one is for OpenCV and this one is for CV Zone. Let's run that and see if it works. And there you go. We are getting something, but it is wrong. So why exactly is it wrong? So we are getting X1. What happened here? So X1, Y1, and then W and H. So okay, something seems wrong. So let's try that. Let's just get these values and we can subtract to get the width and height. So the width and height equals x2 minus x1 and then y2 minus y1, and hopefully that will work out. So let's open this up and we can remove this. And here for the bounding box, we can simply write x1, y1, and width and height. Let's try it this way. Hopefully it will work. There you go. So it works now. So we have the green boxes, and then we can also have, for example, for the phone, you can see it's a little bit fancier. Again, you can change the colors of these edges. You can change the color of the inner rectangle and all of that. All of this information is given here. If you click on the control and click on corner rectangle, here you will see, where is it? It's corner rectangle. There you go. So it will show you this is the length and this is the color for the corner, the color for the rectangle, and the rectangle thickness and the thickness of the corner, and all of these details are given here. So you can check here, and based on that you can apply this. Okay, so this is good. So the next step would be to actually get the confidence values and the class names. So we don't have the class names of yet, so we only are showing the bounding box. So let's find out the confidence first. So the confidence is conf equals bounding box conf 0. So this is the confidence. So let's print that out and see if it works. So if we go down, and there you go, you can see the confidence values, but we want it to be rounded. So what you can do is you can use math. So imports math, and then over here you can change this value. So here we can write math dot, you can write ceiling or floor, it's up to you. So ceil, and that's it. Or based on what exactly do you want to round it off. So we want to round it to 2 decimal places. So we are going to multiply it by 100, and then we are going to divide it by 100. So that's the idea. So if we check the confidence values now, it will be 2 decimal places. So hopefully that should be good. And we are getting 1. Because we made a mistake here, it should be, the bracket should be here. So you are doing the ceiling for this, and then you are dividing it by 100. There you go. So now you're getting 0.94. So that is good. Now we can display it. So to display, we are going to use CV Zone. Now, what exactly are we going to display? We are going to display the confidence and the class name. So we need a box, a rectangle, on top of which we can display this. Because if we just display it on the image, it is not very clear depending on the background. So if the background is in contrast, it will actually display well. If they are pretty much the same color, it will fade away. So that's why we want a rectangle, and on top of the rectangle, we want a text. Now, if we create a rectangle using OpenCV and then we put the text on it, then it won't be centered. If the text is bigger, it will move away, it will move out of the box and things like that. So in order to fix that, we have a function in CVZone that will create the rectangle. It will put the text on the rectangle and it will center it based on the length of the text. And all of this is done automatically. So we can write here CVZone dot put text rect, and we are going to give in our image, and then we have to give in the text. So the text, let's put it an F string for now, because later on we are going to add some stuff to it. So the F string will contain the confidence for now, and then we'll give in the position. Now the position should be the starting value of our X and Y. So it will be X1 and Y1. But because Y1 will bring it a little bit down, we wanted to push it up a little bit. So we can say minus, let's say 20 or 30 or 50. Let me check. Something like that. So let's run that and see if it works. Now this will give us an issue, and I will tell you what that is. There you go. Now it's giving us 0.96, and if I bring this in 0.94, that's good. If I bring in my phone, there you go. If I push it up, it goes up. If I bring it down, it goes down. There you go. So if I go up a bit, there you go. So that's the idea. But here the problem is that if I go up, you can see the text actually goes out, and that is not what we want. We want it to display. So what we can do is we can write here, take the max, whether it's 0 or this value, and take the max whether it's 0 or this value. So whichever one is bigger, because if it goes in minus, then use 0. So it will not go above that. It will stay within. So let's try that out. There you go. It doesn't seem to work very well. If we go here, if we go to the side, it's working on the side, but it's not working on the Y, because we already have a minus 20 in there. So let's remove the minus 20, and hopefully this will work better. Or what we can do is we can put here 20. So if we go up, let me just go like this. Yeah, it's not working very well. So let's try 20 or Y1. Yeah, now it's better. So maybe make it 35, so it doesn't go beyond that. There you go. So now it's actually showing us. So if I have this remote and if I push it up, the confidence level stays there, even though it's going out of the image. There you go. So that's good. That's good. Let's see the phone. Yeah, it's working fine. Okay, so this is good. Now what we need is the class. So we need to know what class are we detecting. Is it a person? Is it a car? Is it a bike? What exactly are we detecting? So this is based on the Coco data set. And what we can do is we can get the class names for that. So I've already created what do you call a list, and you can get this list from our website. Again, you can download it for free. Now if you don't want to do that, the other thing you can do is you can simply type it from here. So right now you can see it's showing the complete thing on the screen. So if you want to go ahead and simply type it out, you can type all these 80 classes. So person, bicycle, car, motorbike, airplane, blah, 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 and all of these. So it should be in a list called class names. So once we have that, we need to find the ID number. So if the ID number is 0, it will be a person. If the ID number is 1, it will be a bicycle. ID number 2 is a car, and so on. So what we need to do is we need to find the the class. So here we found the bounding box. This is for bounding box. Let's write here bounding box. This here is for the confidence, and now we are going to do it for the class name. So for the class name, what you have to do is you are going to use the same format. You will write CLS. You can't write class because you can't use class for obvious reasons. So here you will write class CLS and then box, and you will write here CLS. So that will give you the class name. So let's print it out, or let's put it on the rectangle. So let's remove it here, and we will put it directly on the rectangle. We will write here CLS. We'll give it a space and then this. There you go. So this is for the confidence, this is for the class, and let's see if that works out. So right now it will give us the class ID. It will not give us the actual name because we are not referring it to our list. Once we refer it to our list, it will give us the name as well. So for now, it will just give us, it should give us ID number 0. So here you can see 0.0. It's decimal places. I'm not sure why, but we will figure that out. The phone is 67. That's a very high class. Remote is 65. So what about the chair? Can you find the chair? Can you find the chair? It's confused about the chair. Anyways, so what we have to do is instead of class, what we will write here, we'll write here class names, and then we will put in here class. But if you remember, it was a floating value, so we have to convert it into integer. So we'll put it here as integer, and then if we run this now, this time around, it should give us the class name as well. So if we open this up, here you go, person, 0.96 confidence. If we move around, that's a suitcase. I'm not sure why. So sometimes it's a chair. And then we have the remote. That's very good. Then we have the phone, the cell phone. That's very good. So that's the basic idea. And let's see the pen. Oh, it's actually a toothbrush. I didn't know that. So it is actually detecting this as the toothbrush. That's fine. Okay, so if you wanted to check it on a video, you can do that too. And if you wanted to make these names, these labels a bit smaller, you can do that too. So here in put text rect, here you can write scale, and you can give in, let's say 0.5. So that will squeeze everything down and it will make it smaller. This will be helpful in case you have a lot of detections. For example, you have a lot of cars on a highway, or you have a lot of people being detected. So this will make it easier. So there you go. But then it's a little bit harder to read. So you have to change. Let's say we'll put 0.7. Then you also have to change the threshold. The thickness. The thickness. Let's put it as 0.5. Actually, the thickness is not 0.5. If we check the default thickness, it is no, this is not the corner rect. Where is put text rect? Put text rect is here. The default thickness is 3, so let's put it as 1. So if you put it as 1, hopefully we'll be able to read it even if it's a bit smaller, because we have drastically reduced the scale from 3 to 0.7. So the thickness, well, I don't think we can go below 1. I'm not sure. So there you go. Now you can actually read person 0.9, 0.6. So if you bring in the remote, you can actually read it. So that's how you can increase and decrease the scale for it. By default, it's 3 and 3. So it's up to you if you wanted to check that. Okay, so actually, let's keep it there because we are going to try it with a video, and videos, they usually are bigger. So let's put scale as 1, just a little bit bigger. And you saw that the box actually scales up and scales down automatically. So that's the best part of this function. Okay, so let's try it with some videos. So what we will do is we will copy, and we are going to paste our videos folder in object detection YOLO. So here we have some videos: bikes, cars, motorbikes, people, PPE2, PPE3. So all are these are different videos we are going to use throughout the course. So we have all of them in one folder. So here, instead of video capture 1, let me copy that, and I will write here for webcam, and here we will write for video, and we will remove for the webcam. And for the video, all we have to do is we have to point it to the correct path. So here, if we go back, we will go to videos, and in the videos, let's try bikes.mp4. And this is the size and all that. So in case of the video, you cannot actually set the size. So let's put it here with the webcam like that. So for the video, that is good. Let's run it and see if it works. There you go. So we have a lot of people, and we have bicycle, we have person, we have car. It's a lot of detections. We have traffic light being detected as well. So that's pretty good. And then let's try with cars. Again, you can try with different versions. So there you go. We have some cars being detected. Looks pretty good. And then we can try with motorbikes.mp4. There you go. So we have some cars being detected. We have motorbike, we have person. So those are some pretty good results. Let's try it with the large version. Same video with the large version and see what happens. Most probably it will be a lot slower. There you go. And but we are getting better results in terms of detections. So that's good. Okay, and then let's put it back to nano and the people. Let's try people. P-E-O-P-L-E, people, and let's run that. There you go. So we are detecting people as well, and that's pretty good. So this is the basic idea of how you can use webcam with YOLO version 8 to detect these different objects. And this is quite an efficient way to do it. So later on, we are going to use it. So right now we are actually using it with CPU. So that's why when we go to the large version, it actually is very slow. So in the next chapter, we are actually going to use the same code, but we are going to run it with the GPU. So it will be much faster than this. So let's go ahead and try that out. Now, in the previous chapter, we saw that how we can run YOLO version 8 with our webcam, and we took the help of OpenCV to actually do it. Now, the problem that we saw that it is using a CPU to actually run all the computation. And while I do have a very good CPU, which is Core i9, and it is 12th generation, it is still unable to handle real-time information when it comes to the large version. When we are using nano version, it's fine, but when it comes to large or medium version, then it lags very much. So as you can see here, if we run it, right now we are detecting a video, and then we are running a video with YOLO version 8 large model, and you can see the lag is very much. So it takes almost 300 milliseconds to run an inference. So only 3 frames per second, you can say. So that's not very good. So what exactly can we do? We can use our GPU to actually run it, and hopefully the GPU will give us real-time results. So how exactly can we run a GPU? So first of all, you need to have NVIDIA's GPU. You can check the GPU level on their website, the compute capability, and based on that, it will perform very good or very bad based on how powerful it is. Now, when it comes to installations, there's a lot of installations required to run the GPU, but it is all well worth it, because once you actually get it running, you will be able to run your GPU, and you will be able to run your YOLO version 8 in real time. And that is something that is very good to know. So I've listed down everything in detail. So let's go ahead and follow those steps. The first thing you will need is Visual Studio. So you have to install Visual Studio. This is the requirement for the CUDA toolkit. So this is the CUDA toolkit. So this is the requirement of this kit. So you have to install this first. So Visual Studio, but what exactly do we need in Visual Studio? Once you run it, you have to download the community version. So whichever one is the latest one, you can download that. But then the biggest thing that we need is the development with C++. So you will need that to install that as well. So make sure you install it. So once we have that, then you have to go ahead, and this will take a while because it's quite a few GBs. So it will take a while to download and install. Once that is done, you will go to the official NVIDIA's drivers. So for example, I have the NVIDIA's RTX 3080 Ti. So I will select the GeForce. In GeForce, I will select the 30 series, and then GeForce RTX 3080 Ti, and I'm using Windows 10, so I will select that. You will select the studio driver and English, and you will search, and you are going to download it. Now this is a simple wizard. You have to click next, 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 and it should install quite easily. Once that is installed, you will go ahead and install CUDA toolkit. So CUDA toolkit you can install by going to their website. So this is for the NVIDIA developer. You will click on Windows, then x86-64, then you will click on 11, and then you will download the local version. So I have, I believe, CUDA 11.6. Let me check. So once you download, it will install, and I will check my version as well. So it will install in program files, and if you go down NVIDIA GPU computing toolkit, and if you go to CUDA, this is 11.5. So I have 11.5 based on the version, the latest version you can download as well. So here it's 11.5. We will open that up, and you can see again, this will be an installer. It will be a wizard. You have to click next, 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 install it in C, and in C, this is where you will find all the files. So keep this folder open, because next we are going to install CUDA DNN, which stands for Deep Neural Networks. CUDA Deep Neural Networks. So again, you have to go click on download the CUDA DNN. And this will need the registration on their website. So make sure you have registered, and it is free to download. So just make sure that you have registered, and it will let you download the CUDA DNN. So once you download that, this is what you will get. So make sure the versions are compatible. So right now this is for 11.5, which I installed as the toolkit. So I have to download it for 11.5, the CUDA DNN. So this is what you will get. So if we open up our folder to install this, all you have to do is you have to open up your folder here. So you will see here you have a bin folder. So this is the CUDA toolkit. I don't know why it's so hard to pronounce this. So this is the CUDA toolkit. So this is that, and this is the DNN. So if you go to bin, here you have a bin folder, here you have a bin folder. Open up bin and open up bin here and copy all of these files and paste it here. So just drag and drop. So I have already done that. So it will ask me to do it again. I will not do that again. So then you will go back, and you will go back here. We have already done the bin. Then you will go to include. So in include, again, you will open include here, copy all these files, drag and drop them here. So in the main folder, like that. So then you will go back and then you will go to lib, and inside lib you will see all these files, but here you will not paste them directly. You will go to x64, and over here you are going to paste all these. So drag and drop all these over here. So this way it will install your CUDA toolkit along with the CUDA deep neural networks, CUDA DNN. So this is basically the installation. And one last thing you have to do is you have to go to your environmental variables. So you will click on edit system variables, and here you will go to environment variables. And over here, you will go to CUDA path 11.5. So this is the version that I have. And you will make sure that it points to the correct directory. So if you remember, we had it in program files, NVIDIA GPU Computing Toolkit, CUDA, and then version 11.5. So make sure this and this, they are pointing to the right path. So if they are pointing, then it's fine. If they are not, type it in, make sure they are in the correct path. So you hit OK, and that is it. So now the drivers and the CUDA toolkit and the CUDA deep neural network is installed, but there is one more step. We do need to install PyTorch, which is compatible with CUDA. So here you can see in the requirements, we have already installed Torch, but now we have to install the Torch, which is compatible with the GPU or with CUDA. So how can you do that? We can go to their website. So this is the PyTorch website, and this is how we can install. So we are using the stable version for Windows. We are going to use pip to install, and we are installing it on Python, and we are installing for CUDA 11.6, and this is the command that we need to run. So we are going to copy that. Again, I will share this command so that it's easier for you to install. So you will copy that, and here at the bottom, you are going to go to terminal. Now, this is very important because some of you might make this mistake, and it is very frustrating if you make this mistake. Make sure you are not in local. Click on this down arrow and select command prompt. Because if you are at local, it will install it globally. We want to install it in this virtual environment. So you have to go to the command prompt, and here you can see it's installing it in the virtual environment. So here we are going to paste our link, and we are going to press OK, or we are going to hit enter. So this will take a while. Because I have done this already, it has all these files archived in the cache. So that's why it is able to install this very quickly. Otherwise, it will take a while to actually install all of these. So once it is done, we can go back and we can close all of these. And here in the webcam, we can right click and we can run YOLO. So if it's actually using the GPU, then it will write here GPU. So right now it's not actually showing GPU. So it means there is something wrong. It did not install it properly. So if we go to File, Settings, and Interpreter, if we go to the torch over here, it is using the same torch that we had earlier. So it's probably not using it properly. So what we can do is we can uninstall just to make sure, and we can uninstall the torch audio and the torch vision. We can uninstall those. We'll press OK, and then we will go to our terminal, and then we will run the command again. So again, you can see it is using the cached. Otherwise, it is quite a big file. It's almost 2.4 GBs. So it will take a while to download and install. I think what happened earlier was that all the requirements were already satisfied. The torch was there, vision was there, so it didn't actually reinstall. It didn't install anything. So I believe that's what happened. So you need to uninstall and install again. So it is currently installing. So let's see how it works. So it is saying that requires a later version of OpenCV. We are using this. I believe it should be fine. So otherwise it has installed. So let's run that and see if we are getting. So it is updating. That's why it's not running. Let's run that again. There you go. So now you can see it says Ultralytics YOLO, Python, blah, 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 CUDA 0, NVIDIA GeForce 3080 Ti. So this means now it's not using the CPU, it's actually using the GPU. And if we open up, there you go. Now it's lighting fast. So it is using the GPU. Earlier it was using the CPU and it was dead slow. But now it's using the GPU. And remember, we are using the large version for this demonstration, and still it is running real time. So that is very good. It means the GPU has been running properly and it has accelerated our video, our inference, and that's how it's running. So right now the inference is 10.5. So 10 milliseconds. Earlier, the inference was 300 milliseconds. So that is a difference of 30x. So that is a very big difference when we are using the GPU. So that's great. And again, if you run into any issues, go back and check the video again. Follow through the steps one by one and it should work fine at the end. So again, it's a big difference. So it's well worth trying this. And if it runs properly, you will have a much faster system that will be running YOLO in real time. Do you want to implement your computer vision ideas to solve real-world problems? Or upgrade your resume by enhancing your computer vision skills? Then the computervision.zone is the perfect platform for you. CVZone is a one-stop computer vision platform with over 100,000 users with courses sold in over 80 different countries. If you want to commercialize your computer vision ideas, then the Computer Vision Web Development course is the perfect course for you. Here you will learn the basics of web development and computer vision, as well as how to integrate them to solve real-world problems like customer engagement, car counter, face attendance, shirt size measurement, and a lot more. Advanced Drone Programming is another great course that focuses on the practical implementation. Here you will learn the basics of drone programming as well as advanced concepts like face following, body following, gesture control, and a lot more. If developing mobile apps is your thing, then check out our Computer Vision Mobile Apps course. Here you will learn the basics and create several apps including object detection, augmented reality, face detection, document scanner, and a lot more. The best part is that you will create a single app that will work both on iOS and Android. If you are passionate about integrating hardware with software, then check out our Computer Vision Arduino course. Here you will learn the basics along with amazing projects such as conveyor belt assembly, face tracking, lamp gesture control, face door lock, and a lot more. The Computer Vision Game Development is another great course where fun meets programming. Here you will learn to create games such as Fruit Ninja, Balloon Pop, Squid Game, Cookie Cutter, all using the latest computer vision techniques. Not only that, you will learn to compile your awesome game to an exe file to make it accessible to all. You can also learn to implement computer vision on embedded devices with our Computer Vision with Jetson Nano course. Here you will learn the basics of Jetson Nano and computer vision along with creating exciting projects like lane following robot, eye tracking, object following, and a lot more. All these courses have a clear path from basics to advanced with maximum knowledge in a short amount of time. So check out the links in the description to get started with your computer vision journey today. So now that we understand how to run YOLO and how can we run using GPU, we are going to create some projects out of this. So the first project that we are going to do is a car counter. So within a video, we are going to count the number of cars that pass a certain region. So to do that, we'll first create a new folder. We'll go to, oh, not a new file. We'll go to new and we'll click on directory. And here we are going to write project one. And the name of this project, we are going to call it car counter. So within our car counter, we are basically going to copy the code of YOLO webcam. So we will copy YOLO webcam and we are going to paste it in the project one. So here we will call it car dash, let's write it capital, car dash counter dot py. So we will have the exact same code that we were running earlier, and all we have to do is we have to make sure it's running with the videos. We can remove the webcam part, and we are going to run cars.mp4. So we will have a lot of things done and set it up already while we start this project. So right now you can see it's running on GPU. It's using 3080 Ti, and there you go. We are getting the cars and we are getting their bounding box information, their class, their confidence. And you can see when it's too small, it's not actually putting the corner rectangle properly. So what we can do is, first of all, let's fix that. So here, where is it? Corner rectangle. What we can write is the length equals, I think by default it's 30. Yeah, it's 30 by default. Let's put it at 15. So this is the length of the corner. So the green part that you see, that is what we are referring to. So we can make it smaller. Yeah, so there you go. Now it's smaller. So the green part. And if you wanted to, you can even reduce it further. You can make it, let's say 5. Then it will be really small. Let's see how that works out. There you go. It's too small. Maybe 8 or 9, let's say. There you go. I think this is better. Okay, so we have the cars coming in. We have the rectangle on top of it. We can actually make it smaller so that we can see it better. So let's make it 0.3 or let's say 0.6. And the thickness is still 1. We cannot reduce it further, I believe. So there we have it. Now we have it smaller, but you can see the title itself is smaller, but there is some offset around the region, which is quite huge. So we can reduce that too. So there's a variable called offset, and by default, I believe it's 15. Do we have an offset here? No, the bounding box. Yeah, put text rect. We have offset as 10. So let's make it 5. Or let's put it 3 because we don't want a huge offset. We want the cars to be visible. There you go. So now it's much better. You can see we have the offset and we can see the cars coming in. It looks good. Okay, so this is the basic idea, that we have these cars coming in. Now, the thing is that it might not be a car, it might be a truck, but then what exactly are we trying to find? So if you just want to do cars, you can add a if statement that if it's a car, then detect it. Otherwise, we can find out what are the vehicles that we want to find. For example, in our case, let's say we will detect the car, we'll detect motorbike, we'll detect bus, and then we will detect truck. So these are the 4 categories that we are going to detect. So if we go to our cars video, let's open that up. There you go. So if you go a little bit back, there you go. I believe this will be detected as a truck. This is a car, that's fine. This is a motorbike, so we want to detect that too. And then later on, we also have, yeah, I believe this will be detected as truck as well. And this should be detected as a bus. So we have these different categories and we want to detect all of them. So in that case, first of all, we have to give an if statement that only detect these categories. So here, what we can do is we can write here current class equals class names at CLS. So this will give us the class name. So over here as well, instead of writing this, we can write current class. And over here, we can write if the current class equals car, then only we are going to display it. So in case of motorbike and in case of the truck, it will not get detected. And what we can do is we can put a 0 here. So every time we press the keyboard button, it will go forward. Otherwise, it will not go forward by its own. So there you go. I will keep pressing and let's move forward. And here you can see it is detecting it, but it is not displaying the confidence and the class value. Over here as well, it's not because we are displaying the rectangle. The rectangle is displayed here. The rectangle is, if you wanted to remove that as well, we can do that. But right now it is not displaying the confidence and the class values. So that is what we are trying to do. So here it's not detecting it. So it means the motorbike is not being detected. And then here the truck, as I mentioned, it's not being detected. Then let's move on to the bus. So as you can see, the bus is detected here. You can see it is detected, but it is not classifying it because we said that only when it's a car. So this is a bus and this is a truck. It's not detecting these two because we did not clarify. We did not define them. So here we can say, and we can also put the confidence level. So if the confidence level is very low, then you should not display. So here we can write, and confidence is greater than at least 0.3. So that's what we are writing here, that if the confidence is greater than 0.3 and it's a car, then only you can detect it. So we have 4 categories. So we will write for all 4 of them. So we'll write here, it's a car, or it's a truck, or it's a bus, or it's a motorbike. So let's go down, or it's a motorbike. We have motorbike, right? Yeah, we have motorbike. So car, motorbike, bus, and truck. So these are the ones that we're detecting. Rest of them we will not detect, and we will not even put the rectangle around them. So we can bring it down here in the if statement, and we can paste it here. So let's run it and see how it works. So now it will detect only those. So here you can see it was detecting something here. It was detecting probably a traffic sign, but now it's not detecting that because it's not part of it. And here you can see it says motorbike at 0.56 or 59% confidence. So 59% confidence. So here you can see car. This is detected as a truck. This is also detected as a truck. So then we'll move forward and we'll wait for the bus, whether it's detected as a bus or a truck. So this is truck as well, and this is truck as well. Then there you go, we have the truck. So earlier it was detecting as a truck, but here it's detecting as a bus. So actually this gives us a good point that this point is actually where most of the cars will be classified properly. At the very end, it might not classify properly. At the very back, it might not classify properly. But at the middle, it should detect and classify properly. So that is the region where we should count. So this is where it gives us the idea. So if you're trying to find that position, try to loop through these images and try to find that correct position where the detections are correct. So that's how you can tell the good position, where the good position is. Okay, so that's done. So we have the cars now, but as you can see, we have it in the wrong places as well. So for example, we don't care about what's happening here. If we have some counts over here, it will interrupt our count. For example, if a car is going out from here, we don't want to detect that. We just want to detect at this point. on the main road. So you have to constrain your values so to get good results. Otherwise, if it's completely open, it's not constrained at all, you might not get the best results. Okay, so how can we constrain this? How can we make sure that only this region you detect what do you call the cars or whatever the object is? So one thing you can do, which is very simple, and that you can do within OpenCV or within this PyCharm environment, is that you can create a rectangle. So you can crop this image, you can create this rectangle here, and you can say, okay, only detect in this. And how can you say that? You will crop that image, and that image you are going to send it to your detector. But that is not a very good idea because the shape over here is not rectangular or not square. So what we want is the exact shape. So how can we do that? Now, it is very simple. We will go to canva.com and we are going to create a new design. And in this new design, this design is 1280 by 720. So this is the size of our video, and that is exactly the size of the design. And then we are going to import this video. So here, this is the video. You can see it's the exact same one. Now, what you will do is you will resize it so that it is the correct size. It fills up the whole screen. And then you are going to press R. That will give you a rectangle. So with this rectangle, what you have to do is you have to determine the region. So we are going to rotate it and we are going to align it with this dotted line, this lane. We are going to align it with this. And for the other one, we are going to align it with this lane. So let's go ahead and do that. So we will try to align it as much as we can. So something like that. Something like that. So there you go. And you can move it around like that. There you go. So this is the first one. And the second one, we are going to, basically what we are trying to do is we are trying to create a mask so that it only views in that mask region. So we are going to put another image here. There you go, another rectangle here. And then this area again is very small and it's not very useful. So we are going to remove that as well. So we'll create another rectangle and we'll put it over here. Something like that. And at the bottom as well, we don't want to detect. So we'll create another one and we will put it here. Something like that. So depending on which region you are trying to detect, you can create this. So then you're going to select all of them. And you are going to change the color to black. You can do that in the beginning as well. And then we are going to extend it so that only that region is visible. There you go. That's how simple it is. That's how you can create this mask. And all you have to do now is click on the video and delete it. That will give you the white region. So then you can simply share, download, and you don't need transparent background. You don't need to compress. All you have to do is you have to download the image. Once it's downloaded, we are going to import it. So here's the downloaded file. We are going to bring it to our project. So project 1 car counter, and we are going to name it mask.png. So if we open that up in projects, let's close the others. So here, mask.png, this is our mask. So we can remove that. And now what we have to do is we have to overlay these images so that only this region is detected and we only find the cars within these regions. So now what we need to do is we need to import this mask. So here at the bottom, we are going to say mask equals cv2.imread, and we are going to read from our image. So we'll write mask.png. And once we have that, and we get our webcam image or we get our video image, then we are going to overlay the mask on our main image. We are going to use a bitwise operation of AND that will give us only that region. So we are going to say image region equals cv2.bitwise and we are going to give in our image and we are going to give in our mask. and this will give us the img region, and we are going to display that image region. So let's copy that and paste it here. So we'll write it as region, and we will write image region. So let's run that and see if we get that region as well. And make sure they are of the same size. If they're not of the same size, it will not work. Right now, I know it's 1280 by 720. That's why we have created the image of 1280 by 720 of the mask. Otherwise, it will not work. So there you go. This is your mask. This is the image region. And as you can see, it will only detect in this region. That's what we need now. So we want to detect only in this part. Actually, the mask is wrong. It's not perfect because this car is not visible. So this is not correct. Something is wrong. Let's go back to Canva and let's undo. Yeah, this is not correct. We need to go a little bit higher. There you go. I guess this is a better representation. There you go. So then we are going to delete this. So now it is our new mask. Then we are going to download. And then we are going to delete this previous mask, and we are going to drag in our new mask, and we will call it mask.png. And then we are going to run it again, and hopefully this time around we will not face the same issue. Okay, so this is our image and this is our mask. There you go. So if we play it, that seems fine to me. Yeah, that's good. Okay, so now we will send only this image to our system. So in terms of computation, it will be more efficient as well. So instead of image, we will send image region. That's how simple it is. So let's run that. And there you go. So based on our image region, as you can see, only this area is being detected as cars. So within this region, we are detecting cars. Behind it, we are not getting it. On the side, we are not getting it. So only in the middle, in the specified region, we are getting the detections. So if I play it, once it reaches that region, it detects it as a car or a bike and all that. So that's good. As you can see, it looks good. Yeah. Okay. So now that we have a specified region and we can see all the cars being detected, now we need to count them. So in order to count, we need to have a certain region that this is the line. When it passes this line, we will consider it as counted. So we need to know that. Second thing we need is an actual tracker. So right now what we are doing is we are detecting the cars, but in the next frame, we do not know where the car has gone. So what we need is a tracking ID. So if we detect a car in the first frame, we need to know where did that car go in the next frame so that we can assign it the same ID. So in the first one, if it's ID number 1, in the second frame, it should remain ID number 1. It should not go to ID number 2 or 3 or 4 or 5. So this is basically a tracking problem. So within the consecutive frames, we need to find out where is our object moving to so that we can assign them unique IDs. So to count, we need to find first a tracker. So the tracker that we are going to use is called Sort, and you can find it on GitHub. And here you can see it's by Abi Welly. And thanks to him and the contributors who actually created this tracker. And it is very easy to use. And here they are showing us how to use as well. So all we need is this sort.py. So if we click on that, this is the code. What we will do is we will download this file. Of course, this file will also be available with our zip file, so you can find it there, or you can come to GitHub and download it from here. So we also have some requirements. Filter py, scikit image and lap. So these requirements are already fulfilled because we added that in our requirements as well. So filter by scikit image and lap. So these are the ones that we have already installed. So what we need to do is we need to bring in the file. So let me copy that and I will bring it here into our project one. And this is a simple sorter, a simple online and real-time tracker, copyright Alex Beverly. You can see here. So this is all the code. We are not going to do anything to this. All we have to do is we need to know how to use it. So here to import, we are going to write import sort, or actually what we can do is we can write from sort import everything. So it will be easier for us to work with. So this is what we are going to do. And then we are going to create an instance for the sorter. So what we will do is sorting, or let's call it tracking. Tracker equals sort, and then we have to give in the maximum age. So what is the limit of the number of frames that it is gone and we still recognize it within that region. So if ID number 1 is lost, how many frames do we wait to detect it back? So the higher, the longer it will wait for it to come back. So maximum age, let's put it as 20. Minimum hits, let's put it as 2. And then we have the IOU threshold. Again, these are parameters that you can change, but they have default values as well. If you go to sort, maximum age is 1, which is really bad. It's not really useful. Then we have minimum hits as 3 and the IOU threshold as 0.3. So I will keep them the same. Let's put it as 3 and IOU threshold is 0.3. So again, this we have explained in the theory part. So if you're not familiar with this, go ahead and check that out. This is the intersection over union threshold to find how good the overlap of the bounding boxes is. So these are the values. You can play around with them and see what type of results you get. Now, in order to run this, it's very, very simple. All you have to do is you have to write tracker.update, and that's it. So you need to update it with a list of detections. So we will write here detections. Now we need to find these detections, which we already have, by the way, because here we have the bounding boxes. But what we need to do is we need to put them in an array. We need to put them in a list. And we need to make sure that the format is exactly what this requires. So what format does it need? We don't know. We can go into the sort and we can check here. So in the update, it says this is a numpy empty. So by default, it's a numpy array of 0 by 5. So this is the dimension. So we have 5 values. So the format is x1, y1, x2, y2, and the score. So this is what we have to feed in. And what do we get out of it? We get a rect concatenated. Maybe it's not mentioned here. What we get as the output or the return is x1, y1, x2, y2. And then we also get the main thing, which is the ID number. So that is what we need. So let's just copy that. So where is the update here? So our detections, by default, if we don't have any detections, this should be our type. So we should have a numpy list. So right after we get the results, we are going to create a list or an array of detections. And this will be empty, 0 by 5. So that is the idea. And once we have that, then we are going to, once we detect it as a car or a truck or a bus or a motorbike, and the confidence is greater than 0.3, then only we are going to save it to our detection list or detection array. So then what we are going to write, we are going to write that our current array equals numpy dot array, and we are going to give in the x1, y1, x2, and y2, and we will also give in the confidence value. So these are the 5 values that it requires. And then what we have to do is so normally if we have a list, what we do is we write dot append. So if you want to add it to the list, you just write append, it goes down, it goes down, it goes down like that. But in a numpy array, we don't write append. What we do is we stack. So we will do a vertical stack. That's how simple it is. So we'll write detections equals numpy dot vertical stack, and we have to give in our current detection, the old detections that we already had, and the current array. So we stack them together. So that's the idea. So once we have these detections, now we can simply send it to the updates. And again, this update is not dependent on what did we detect new, because we need to keep updating it from the previous times as well. So we already have an empty one and it will keep updating. So here we have the detections, and then we need to get the results of this. So we can write here results for the tracker equals this. Results of the tracker equals this. And then we can loop through the results of this tracker. So you can write, for example, for results in results tracker, we are going to get the x1, y1, and the x2 and the y2 and the ID. So which is the most important thing, that we get the ID, and that is basically the result. So let's print out the results. Actually, we can print out this as well. Later on, we are going to use this. That's why we are writing it like that. So let's run that and see if we get something. Hopefully there are no errors. Otherwise, we are heading in the wrong direction. Okay, there you go. So now we have our 3 IDs. Perfect. So we have ID number 1, ID number 2, ID number 3. Let's press spacebar, and then again, it is moving on to the next one, and you can see it's the same ID. Then it moves on to the next one, and you can see the 4th one has come up and it has increased the ID. There you go. And then the 5th one comes in and it shows. So it couldn't find probably the other 2, and that's why it's showing only 3. Okay, so in order to understand this better, what we are going to do, we are going to display these ID numbers, so it will become easier. So instead of showing it here, or let's do both. We'll show it here and we will show it here as well. We'll keep the thickness of this bigger. So we are talking about the rectangle. So the rectangle thickness here, so rectangle thickness equals, let's say 5. And for the other one, we will make it a little bit smaller, so we can see what is the actual detection and what does it think, where is the tracking part. So how well the tracker detects the bounding box. So let's try to find that. So what we'll do is, again, we will simply use these values. Are they integers? Yeah, they seem to be integers. So what we can do is we can simply create our corner rectangle. So we will write here CV zone dots corner rectangle image, and we have to give in the bounding box information. So the bounding box information will be like we did here. Let's copy that, and actually let's copy this corner rectangle because we're lazy. So there you go. So x1, y1 width and height, and this time around we'll put the rectangle as let's say 2, and we will put it as blue, the color. So the color for the rectangle, let's put it as 255 0 and 0. And let's show the ID as well. So Here we are showing using put text rect, right? So we will copy that and we will paste it here. And instead of confidence and current class, we are going to display ID. It didn't show? Oh, I is capital, my bad. So this here, why did I put I capital? Let's put it small, ID, like that. Okay, so ID, and yeah, that's fine. And positioning is x1 y1. So x1 y1 is already bugged, like it's something is already there. We have the confidence and all that. Actually, let's remove that because we know already we have the classes and all that. But it's car or bus or whatever, so we can remove that, and now we'll get the ID instead of that. Okay, so let's run that and hopefully we'll get some good results. So expected sequence length 2 got 4. What is happening here? So it detected something, then it said corner rectangle, we have an issue. Image color RT, OpenCV by argument, rectangle. Expected length 2 got 4. Okay, so we are getting an error here, the corner rectangle. Why are we getting an error here? Let me check the corner rectangle. Color R and color C. RT, or is it TR? It's RT. Yeah, RT. Length is this. Let's print out x1. I just want to make sure that x1 is actually an integer and not a floating value, because if it is, then we have a problem. There you go. That's why. Yeah, that's the issue. So we have to do the same thing we did earlier. We have to do this. We have to convert them into integers. There you go. So let's run that and hopefully it will be fine now. There you go. So now it's showing us, okay, the IDs are very small. Let's make them bigger. So put text rect ID max is this and that. Scale, let's put it as 2. And thickness, let's put it as 3. Offset, let's put it as 10. So it will be big values. We can clearly see what's going on. There you go. Point, hate the point. So ID, we need to convert the ID into integer as well. So let's just do it here, integer ID. Okay, so there you go. So this is ID1, ID2, ID3. Now is the moment of truth. So if we go to the next one, these IDs should remain same. If they flip around, it means it's not tracking, it's only detecting. So if I press spacebar, and there you go, it's the same. So if I press spacebar again, it's the same. So 1, 2, 3, 4. If I keep pressing, there you go. So the 4 was lost, but it kept it, it brought back the 4 from where it left off. And you can also see the blue line. The blue line is basically what the tracker is detecting, and the purple one is what the detector or the YOLO is detecting. So if we keep going forward, you can see this is now 5 and this one is 9. Now, this is not an issue, because if it doesn't go to 5, it might have detected some wrong IDs. But as long as the ID remains the same, if 9 remains 9, then it's fine, because we will have a line after which we cross, we will detect it or we will count it. So that's fine. So there you go. It's 14 is 14, 12 is 12, 18 is 18, 19 is 19, 20 is 20, 23 is 23, 24 is 24, and that's all good. So we can make a line here. We can make a line here, and whenever that line crosses, whenever that ID crosses that line, we are going to detect it as a count. Now, how can we do that? It's very simple. all we have to do is we have to first of all create the line. So we are going to write here that our line equals, so this value should be actually there's image region coming here. Let's remove that because we don't need that anymore. Now this line, I have checked the values already, so we are going to put that, let's call it limits. Let's call it limits instead. And then we are going to write here 423, 297, 673, and 297. So these are the limits. And using these limits, we are going to create a line. So this line, let's draw it after the tracker. So here we'll write cv2.line, and we'll give in the image, and then we have to give in the points. So the points are basically limits at 0 and limits at 1. Then the second point will be limits at 0, limits at 2, and